I'm now talking to Jim O'Callaghan of the EnOcean Alliance. Hi Jim, tell us a little bit about the Alliance and its background and the directions you're going in these days.
Thanks, Vince. The Alliance is a consortium of more than 350 companies offering 1,200 different interoperable products, all communicating around the IEEE standard certified for energy harvesting power devices under the EnOcean Alliance.
Okay, and let's look at the very basics. I mean, how does EnOcean differentiate from other wireless technology standards?
The most critical element of differentiation is the standard was derived to utilize energy harvesting. Energy harvesting is the converting of ambient energy into usable electrical energy to power primarily wireless sensor devices. It's since gone on to become more broadly used in actually powering actuators, for example, valves and air vents. Energy is harvested by these members from a variety of sources. For example, light, indoor light, solar cells, linear motion, pressing of a switch, turning of a handle. We also use thermal energy, the differences between temperature. A difference of as little as 3 degrees C is sufficient to generate energy. These again are being used on things like radiator valves to open and close the valve and provide the wireless telemetry. There's some new advances in energy harvesting coming in the form of rotational energy for things like meters and inductive energy using power in electrical wires to convert.
Okay, so you're eliminating batteries and power sources in a lot of control devices. Have I got that right?
You've got it exactly right.
Yeah.
We like to say that the ideal wireless installation is one you install and forget. You install it and forget about it like you do a wired device. You put it in and 20 years later it's still operating. But you have all the flexibility for ease of installation as well as mobility throughout the time in order to move the device.
So I'm thinking that must make the installation of smart building systems extremely easy by comparison with a system whereby you have to install wires and channel out walls and so on.
Exactly. There's a term that many of the OEMs have coined called peel and stick. So you can literally go into a facility with minimal invasion. And when you look at retrofitting a facility, compared to the incumbent of a wireless technology, you're talking about the pulling of the wires, which is expensive. You don't know what you're going to hit behind those wires. There's many facilities that have been done because they have asbestos, they can't get up in the ceiling. There's others where just the invasion, you really almost have to take a building out of service if you're going to start fishing out wires. Sure. Whereas if you can go in and only access one point, either a gateway or the actuator where there's electricity, there's usually access to it, and you can put in a device that receives the signals, then you can go around and peel and stick these switches and sensors to communicate the needed information to control the system. Conversely, with batteries, we like to say that a battery itself is cheap, but replacing it isn't. Right. And some of the issues that people deal with are what type of battery, what's the life of the device. If you have a power hungry and a power miser device in the same facility, they're going to have different battery change cycles, which means you either have to stock and keep two different types of batteries, or you have to change one more frequently. Then you have the issue of access. Where are those devices or mobile devices? Do I change them on a schedule or do I wait for them to fail? Do I have access to that facility when I get there? And everyone knows about the story of the smoke detectors. You know, something like 20% of all the battery-powered smoke detectors aren't working. And now you talk about, we have many facilities with thousands of devices in them. And if you talk about that issue, it's just magnified. And so eliminating the cost, but also the inconvenience of the batteries and eliminating the wire, I think is really essential and ideal for promulgation of wireless technology.
So from what you're saying, this is a real here and now technology. There are installations, it sounds like lots of installations out there already today.
Yeah, we've calculated that there's approximately 250,000 buildings from the millions of units we've sold. And they've been installed and operating successfully for more than 12 years, which is quite long in this nascent wireless market.
And has the concepts been accepted by the industry, by the installers and so on? Are they liking it?
Yeah, actually they have. Like any new technology, when you first come out, you're introducing wireless and energy harvesting, there was some trepidation. But that's largely been cured by the installations that have been installed with very high node counts. And we're actually finding now in both our direct feedback as well as the industry feedback that the professional community has embraced this technology and sees it as just an alternative. It's more of a mainstream. And that's where some of the elements of the Alliance come in. If you're in this market, you really would like to know that I have a stable technology. This one's been around for a long time. Interoperable, again, hundreds of members. 3, if one of those members or something goes away, or quite frankly, if EnOcean goes away, the technology still exists because the international or interoperable standard is still out there.
It seems like an incredibly attractive concept, just being able to completely do away with battery power for such devices. How would you see EnOcean growing over the coming years, and how wide will it get? How widespread will its use get?
The EnOcean Alliance and the members generally believe that this is fundamentally the right long-term solution, not just for niche markets where wireless is used, but as the main unit. There's no real reason why it should be a retrofit only. It could be new construction because it's already proven to be less costly in new construction and more flexible. So we think that there will be significant more growth as the awareness and acceptance grows in the traditional markets of commercial building. We're starting now to see more adoption in the smart home market as well. And again, we went back to that smoke detector. Yep. You're now talking about going around with security systems and maybe having 20 to 30 devices in a home. Security companies have had to provide a service to go out and change those batteries. As this technology gets more widely distributed, consumers won't want to pay that money, especially when they don't have to. So we'll see it in things like security devices and other sensors and things that monitor your home. We mentioned earlier in the commercial business, lighting control. One of the big drivers right now is LED lighting, where there's this big transition from compact fluorescent, of course, incandescents are being phased out, and LEDs are coming in and are projected to be the majority of the market by 2020. LEDs have 2 advantages. They save a lot of energy, but also they take controls a lot better. They actually are more efficient as you dim them. And so when people are upgrading to LEDs, they're also saying, while I'm at it, I might add controls to this. Things like occupancy, turn out the lights when nobody's there, dim the lights if there's natural light coming through a window, those examples. And so in retrofit, clearly you don't have those control wires in the wall right now. You have power. You can switch it. So you need the ability to communicate those control signals to a device. So integrating a transceiver into an LED fixture and then providing, again, these peel and stick sensors is really common sense while you're upgrading. And as we go into the future, people will say, well, I don't want to face this problem again of where I have wires, but I don't have the right wires. What I'll do is I'll bring power to my device and then I'll use wireless controls for new construction so I have the flexibility to change my building as I need or add devices that communicate as needed.
And does it have other benefits? I mean, apart from replacing batteries, are there ways in which EnOcean can be used which will benefit other applications? I mean, could you put EnOcean in cars, for example, or something like that?
Yeah, we've seen some interesting projects coming in. They aren't on the market yet, but projects coming in. For example, if you think about an automobile, there's wires running all over the place, and those things have to be, they're expensive wires, they have to be environmentally controlled, etc. If you think about lifting a door handle, you have plenty of energy right there to send wireless signals to unlock that or control it. You think about clicking a seatbelt, especially in seatbelts and things like buses and large vans where you might have removable seats, you don't know. So applications like those are obvious. Also sensor applications. If you can distribute and position sensors where you want them in the vehicle without so much regard for where can I get a wire harness around this moving part, that also makes sense. And so what seems to be a pretty reasonable approach long-term is a vehicle has a dedicated receiver, and that dedicated receiver can receive all sorts of information and then take that information and distribute it, either actuating something, sensing something, controlling something.
What section of the spectrum is this operating in, Jim?
The EnOcean Alliance standards are currently in the sub-gigahertz band. So in Europe, in places where that follow Europe as far as their RF. They use 868. In North America, we use 902 megahertz, and in Japan, 928. There's some real advantages to sub-gigahertz bands, one of which is that they are significantly less occupied than the more popular 2.4 gigahertz, as an example. And that means we deal with a lot less interference. And when you're a low-power wireless device, you want to have radio success as quickly as possible. You don't want to have to get into all sorts of sophisticated handshaking. So that's a real advantage. And the second is the physics of wireless. Mm-hmm. As you go down in the frequency, you increase the range for the same amount of power. Again, when you're using low-power electronics, our devices tend to reach about twice as far as you would get with say, a Wi-Fi type device. Again, from a self-powered wireless device.
That's an interesting point. What sort of range are you talking about? And how critical is it for the type of applications that EnOcean's used for?
Range is critical because you never know what type of environmental conditions you're going to encounter. And again, the more range you have, the less infrastructure in the wireless you need. Mm-hmm. Typical ranges for us would be in the neighborhood of, say, 25, 30 meters, mm-hmm. 75 feet through walls in a traditional commercial or residential building. And what we find most critically is the devices you're controlling. If you're controlling a light switch, you can usually see that light. And so a lot of it is local room. But then if you have the benefit of much longer signals, you can get to things like gateways. And there's a number of gateways that then bridge to common building protocols like KNX, BACnet, LAN, or to IP. And so if you can get longer range from your devices, that means you need less of these gateways, and you can cover a building with fairly simple infrastructure.
Okay, well, thanks very much for that, Jim. It's hard to see how we won't be seeing a lot more of EnOcean over the coming years.
We certainly plan on it. Thank you.